Hello everyone and welcome to STEM School. So in today's video, I'll be explaining how to calculate the roots of quadratic equations, and of course I'll go over some exam questions so that you guys are best prepared for the different types of questions they can hit you with in the exam. So before I begin, please do remember to hit the like button and consider subscribing to the channel, that would be great. Alright, let's get started. So hopefully you'll have seen quadratic equations before. They have this form here, y is equal to ax squared plus bx plus c. You have the x squared term, you have the x term, and then you have the number on the end there. So it's a quadratic because the x squared term is the highest power in the equation. So this we can easily recognize what a quadratic is with some examples here. We can have, y is equal to x squared plus 2x minus 3. That's a quadratic. The highest power in this equation is the x squared term. And then we can have something like y is equal to 4x squared minus 4. So this is written slightly differently, but this is still a quadratic because the highest power in this equation is the x squared term, as normal, okay? And then lastly, we can have y is equal to x squared. That's the simplest quadratic equation you can get. So if I told you to solve this equation, then I'm basically telling you to find the values of x by factorising it. Solve to find x, okay? Just by factorising it, okay? So if I tell you to find the roots of the quadratic equation, then it's the exact same thing as that. You're solving this quadratic equation to find the values of x. So in that case, you're finding the roots of the quadratic equation. So it's easier to represent this visually, and in my previous video that I'll link in the description box, I showed you what a quadratic looks like on a graph. It's something called a parabola, a symmetrical curve just like this. I explained that you have some key features on the parabola. So first of all, we'll talk about the turning point, so TP for turning point. So turning point is basically the point on the curve where the curve changes direction. So the curve goes down the way and then it reaches this point and then the curve moves up the way just like that. That's a turning point. So you can also get a parabola just like this, an upside down parabola. So if you think about it like a happy parabola and then you have an unhappy parabola. So in this case the turning point will be here, right? So it occurs at the dead center of the parabola, right? Now, on a related note, what we have is something called the line of symmetry. The line of symmetry. So, of course, the parabola is a symmetrical shape. So, obviously, the line of symmetry will occur in the middle, and you can mirror the curve along this line of symmetry. Now, a common question you could get is give the equation of the line of symmetry. So, what you can notice is that the line of symmetry occurs at the x coordinate of the turning point. So if you know the coordinates of the turning point, then you know the line of symmetry. So in this case, it will be x is equal to 1. Alright, so moving on to the next feature, what we have here is where the curve intersects with the y-axis. This is a common question you could get asked, but what you should know is that where the curve intersects the y-axis is when x is equal to 0. X is equal to 0 there. So what you do is you substitute x is equal to 0 into the quadratic equation, and that will give you the y coordinate. Okay, so that's how you figure that out. And lastly, what we have here are the roots of the quadratic equation. So those are these points here. So these are the points where the curve intersects the horizontal x-axis. This is very important. This is what we want to find. So there are a lot of questions you can actually get about parabolas relating to these key features, so I advise you to check my previous video where I explained them in great detail. But basically you have the quadratic equation just like this, y is equal to x squared plus bx plus c. Now for these type of questions, what they do is they change this form of the quadratic equation into this form of the quadratic equation. What we have is y is equal to x minus a all squared plus b. Okay doke, so to get from this form of the quadratic equation to this form of the quadratic equation, you just have to go through the process of completing the square. Now this is a very useful way of representing the quadratic equation because we can immediately understand useful information about the parabola. So I explained this in great detail in my previous video, so do check that out, but I've left some notes here. So what we have here is if the quadratic equation has a positive x squared, then you know you're going to have a minimum turning point, which is like that, a happy parabola. Now, if you have a negative x squared in the quadratic equation, then you know you're going to have a maximum turning point, which is an unhappy parabola. So just think about it like that, right? Then the third bit of information is that when you analyze this equation, the turning point will simply be AB. So you just need to remember that the equation has to be perfectly in this form. And then finally, the axis of symmetry will be located at x is equal to A. So how do we solve a quadratic to find the values of x? How do we solve the quadratic to find the roots of the equation? Well, you have to simply factorize it. You want to look at the quadratic and make it equal to 0, and then you want to try and factorize into single brackets or double brackets, all whilst looking for common factors, okay? But if the quadratic equation can't be factorized, well, that's when you use the quadratic formula to work it out. So I'll go over some examples showing you the different questions you could be hit with in the exam. Alright, so the first example that we'll do is looking at single or double brackets, right? So whenever you get a quadratic equation, what you want to first think about is, can I factorize this using single or double brackets, right? So let's look at this first example. We have 2x squared minus 6x is equal to 0. So in your head, the first step should always be, can I find any common factors at all? That should always be the first step. So what we have here, we have 2x squared minus 6x. Well, I can take a factor of 2x outside the bracket. So we have 2x, and then let's factorize this properly. Okay, so we always remember to put equals 0 on the end there, right? So 2x, then we can put x inside the bracket. So 2x times x will give us the 2x squared. Then 2x times what is equal to minus 6x will be minus 3. Okay, so that's us factorized that correctly. Now at this stage, to find the roots of the quadratic equation, what you want to do, or simply find the values of x, it means the same thing. What you want to do is this. So you draw two arrows like this, and then you treat it separately, like two linear equations. So we have 2x is equal to 0. So if you divide both sides by 2, you have x is equal to 0. So that's one value of x already figured out. Now let's do this second one. We have x minus 3 is equal to 0. So basically we're dealing with two linear equations. That's how it works, okay? So let's take the minus 3 to the other side. We have x is equal to 3. So that's the second value of x. So we can quickly draw that. So what we draw is, so if you're ever asked to draw a parabola in a graph, just make sure you label both axes, so x and y. So the first root is x is equal to 0, then the second root is x is equal to 3. Now, is it going to be a minimum turning point or a maximum turning point like that? So what you should remember is that whenever the quadratic equation has a positive x squared, then it's going to be a minimum turning point. Okay, so it's going to be upside down. So it'll just look something like this. Okay, doke. So that's the first one done. Now let's move on to this second question. What we have here is x squared minus x minus 12 is equal to 0. So if I was to factorize this to find the roots, well, I can't take a common factor out, right? So my next thing I should think about is, can I put this in double brackets somehow? Can I factorize it like that? So what I immediately do is set up the double brackets like this. Just like that, put the minus equals 0 on the side there. So then since it's an x squared at the start, what you have put here is x and x. And then you analyze the number here, so we have 12. What you want to do is to find a pair of numbers that multiply to make this number, so to make 12. So 2 times 6 makes 12, and 3 times 4 makes 12. You can also get 1 by 12 as well. Now you want to ask yourself, which pair of numbers add up to make the number on the x term. So say if I did 3 plus minus 4, then I get minus 1x. Okay, so that's the mentality you should have. It's just trial and error. So we're going to pick this pair, 3 and 4. So you just need to make sure that the sign convention is right. So you just multiply it out in your head. X times, I can do minus 4x, and then I can do positive 3. Okay, so that's how you factorize it. Okay, so that's the steps to follow. And then same as before, you just draw two arrows and treat them as two separate linear equations. So we have x plus 3 is equal to 0. So that gives us x is equal to minus 3. So that's one of the roots already figured out. Let's do the second root. So we have x minus 4 is equal to 0. So that gives us x is equal to 4 as the second root. So again, let's quickly draw that. So what we have here, we have x, then we have the y-axis. So the first root is x is equal to minus 3, and then the second root is x is equal to 4. Now, is it going to be a minimum turning point or a maximum turning point? Well, the quadratic equation has a positive x squared, so it's going to be a minimum turning point. So it's going to look something like this. There we go. So that's the steps to follow for single or double brackets factorising. But you can also check my previous videos that I've done on that, explaining it in a bit more detail, alright? Now let's have a go at this question. So this question is saying, solve the equation 3x squared plus 9x minus 2 is equal to 0. And you have to give your answer correct to one decimal place. So when I see this question, what I see is a quadratic formula. What I want to do is solve this equation, which basically means find the roots of this quadratic, right? Now, when you see a quadratic equation, you should firstly think, can I put this into single or double brackets? Can I factorize it that way? But sometimes the quadratic equation can't factorize, so in that case you want to use the quadratic formula. And this question actually gives you a clue to use a quadratic formula because it says give your answer correct to one decimal place. This type of question normally appears in a calculator paper in an exam, so that's when you'll be able to do one decimal place, alright? So let's have a go at this. So we have 3x squared plus 9x minus 2 is equal to 0. What you want to do, after you've identified to use the quadratic formula, what you want to do is label the a, b and c to put into the quadratic formula. So what we have here is a is equal to 3, b is equal to 9, and c is equal to minus 2. Now what we want to do is just simply substitute that into the quadratic formula. So what is the quadratic formula? It's minus b plus or minus b squared minus 4ac all under square root all over 2a. Now let's just simply substitute this in. We have minus 9 plus or minus, so we have 9 squared minus, so 4 times 3 times minus 2, that's under a square root, and then 2 times 3, that will give us 6, alright? So let's just keep going. So we have minus 9 plus or minus, so we have 81, so it'll be minus 4 times 3 times minus 2, so that will give us 12 times minus 2, so that will give us minus 24. So I'm going to put that in brackets again just to tidy it up a bit so I don't make a mistake with the double negative. So it'll be minus 9 plus or minus, so 81 plus 24, that will give us root 105 all over 6. Now we're nearly there. So when you get to this stage, what you can do is set up two solutions, right? So the first solution for x will be minus 9 plus root 105 all over 6. And then the second solution will be minus 9 minus root 105 all over 6. So if you notice the plus or minus bit, this is where you separate it at this stage, okay? So what we want to do is just pop this into a calculator, and this is what we get. So minus 9 plus root 105 all over 6 will give us x is equal to 0.2. And then the second one will get us minus 9 minus root 105 all over 6 will get us x is equal to minus 3.2. So just be careful that you remember to put it at one decimal place. Okay, doke? And finally we have a go at this question here. And this is actually a really good question to do because it kind of encompasses the majority of what you need to know for this topic, right? So this question is saying that we have to sketch the graph of y is equal to bracket x minus x bracket x plus 4. And we have to show the points of intersection with the x-axis and the y-axis and the coordinates of the turning point, alright? So there's quite a lot to do there. So first of all, it says to show the points of intersection with the x-axis. That's the roots of the equation, right? So let's have a go at that bit first. We'll tackle it bit by bit. So the equation is y is equal to x minus 6 bracket x plus 4. Okay, so let's tackle the roots first of all. Now, when you want to find the roots of the quadratic equation, you need to factorize it, but luckily this question already gives you it in double bracket form, so it's already factorized. So what we can do here is just draw two arrows like this and deal with the separate linear equations. So the first root will be x minus 6 is equal to 0, and that gives us x is equal to 6 as the first root. Now, the second root will be x plus 4 is equal to 0, and that will give us x is equal to minus 4 as the second root, okay? So if you want to write it in coordinate form, it will be 6, 0, and then minus 4, 0, just like that. So that's us done the first bit already, finding the roots of the quadratic equation. Now what we want to do is find where the curve intersects with the y-axis, right? So let's do that, y-axis intersect. So this is a common question, right? So what you should know is that when the curve intersects the y-axis, you know that occurs when x is equal to 0, okay? So the curve, the quadratic equation, if you know one coordinate, you can find the other part, the other coordinate, right? If you know the x, you can find the y. If you know the y, you can find the x. So if you know it occurs when x is equal to 0, all you have to do is just substitute that into the quadratic equation, okay? So let's do y minus 6, then we have x plus 4. So we want to substitute x is equal to 0 into this equation, right? So it'll be 0 minus 6, then 0 plus 4. So what does that give us? So it'll be y minus 6 times 4, and that will give us minus 24. So we have the coordinate 0 minus 24 is where the graph, where the curve intersects the y-axis, right? So that's us done the y-axis intersect. So let's actually draw what we have here first of all, right? So we have this, and then we have this, right? So we want to label it x, and you want to label it y. So let's first of all put what we know. So the roots of this equation, so we have minus 4 at 0, so we have minus 4 here, and then we can put 6 there, okay? So we put the roots in correctly, and then we know where the curve intersects the y-axis, so we can put minus 24 here. Now, is this going to be a minimum turning point, or is it going to be a maximum turning point? Well, basically, if you remember, if the quadratic equation includes a positive x squared, then you know it's going to be a minimum turning point. So if you look at this equation here, if you multiply this out, you get a positive x squared, won't you? So it's going to be a minimum turning point. So we can just quickly sketch what this is going to look like. So it's going to go here and there. It's a terrible drawing, but you get the gist of it. Now, the last thing you want to find is the coordinates of the turning point. So a good way to work that out is if you know the roots of this equation, then you can find the turning point because the parabola is a symmetrical shape, right? So you can just manually find the middle of this distance. So from minus 4 to 6, it's 10 units, right? So the middle is going to be 5 away from either end. So minus 4 plus 5 will be 1. Okay, so that's how you work out the dead center. So at the dead center, that will give us the line of symmetry, and it'll also give us a turning point here, okay? So the turning point here will be at x is equal to 1, okay? So the turning point, the line of symmetry is x is equal to 1. But we want to find the coordinates of the turning point, okay? Well, if we know x is equal to 1, then we can substitute x is equal to 1 into the quadratic formula, right? So let's do that. So y is equal to x minus 6, x plus 4. So this sub in x is equal to 1 to find the turning point coordinate. So we have y is equal to 1 minus 6, then we have 1 plus 4. So what does that give us? So it will be y is equal to minus 5 times 5, and that will give us y is equal to minus 25. So what we have as the coordinates of the turning point will be, so it'll be 1 minus 25. And there we have it. So we want to label that as well. 1 minus 25. And there we have it. So that was a pretty good example showing the different types of things you could be asked. You know, finding the roots of the equation, and then finding where the curve intersects the y-axis, and then finding the coordinates of the turning point using this useful technique, okay? Remembering that the parabola is a symmetrical shape. So hopefully this video has helped you, and please do remember to like the video and consider subscribing to the channel, and please do join me in my next video where we'll be looking at the discriminant and looking at the nature of the roots of the quadratic equation. So I'll see you guys then.